When we are given a general solution to a differential equation and some conditions, it is possible to solve for the particular solution by solving for the arbitrary constants. So in this example, that is what we will do. So we are given the solution of a second order differential equation, and we know it's second order because there are two arbitrary constants, and we write that down here. It's y equals c sub 1 sine of x plus c sub 2 cosine of x plus 1. And we are also given two conditions. So that is y of pi equals 0, and the other one is y prime of pi equals 0. Now, here we have y of pi, and we also have the general solution. So what we can do is just substitute pi for x's here in the general solution. So if I just substitute pi, and I know that the other side is 0, so I'll just write the 0 first, and then I substitute pi for x's, so that becomes y of pi. And then I have c1 sine of pi plus c sub 2 cosine of pi plus 1. And here we know that sine of pi is 0 and cosine of pi is negative 1. So this equation further reduces to 0 equals, we have 0 here and we have negative c2. So negative c sub 2 plus 1. And that means we now know our c sub 2, and it's just 1. Now we will use the second condition that was given, y prime of pi. But before we can do that, we have to get y prime first. And we can get y prime by differentiating the given general solution. So y prime of x is just, so we differentiate this, that becomes c1 cosine of x, and here is negative c2 sine of x, and the derivative of 1 is just 0, so that's just 0. And now we can substitute pi and 0 here. So let's just write the 0 first, and then y prime of pi. So we have y prime, so that's y prime, and then just put the pi for x. And we substitute the pi on the x's here. That becomes c sub 1 cosine of pi minus c sub 2 sine of pi plus 0. And we know that, again, this is negative 1, and this is 0. And so what we have is 0 equals minus c sub 1. And again, these are just 0, so plus 0. And therefore, we know that c sub 1 is just 0. And therefore, our particular solution is y of x equals, so we substitute c sub 1 here, which is 0, so that's just 0 sine of x plus, so c sub 2, we substitute 1, because it's 1 here, then cosine of x, then we have 1 at the end, and again this will just go to 0, and so the particular solution is just cosine of x plus 1. That is how we determine the particular solution for this problem.